Hello, hello. Okay, so the stream is working fine. So, hey, hello everyone. My name is Varun, and let's start today's LeetCode Biweekly. Before we start the contest, I want to say some few things about today's contest. Though that is, today's problem 3 was much tougher compared to uh, uh, problem 4, in my opinion. Problem 3 was a lot more tougher in terms of thinking logically. And I just want to show my timestamps so that if anyone is feeling bad that they didn't solve problem 3, they can understand a bit from here. Basically, I spent twice as much as time on problem 3 compared to problem 4. Today's it was just uh, different. So I'm assuming that a lot of people came here to solve to check the approach of problem 3. So let's just start the post contest discussion. So our first problem states that there is an integer array nums and you need to consider all pairs of distinct values x and y from nums such that x is less than y and x and y have different frequencies. And among all these pairs, we need to choose the smallest possible value of x. And if multiple pairs have same value, then choose the one with the smallest value of y. So what they are basically saying is, let's say there are some an array of numbers 1, 1, 2, 2, 5, 6, 7, 9, 9, 10. What he's saying is, we need to choose two numbers. Let's say 2 and 5. This is x and this is y, such that x is less than y, with and frequency of x should be not equal to frequency of y. For 2 the frequency is 2 and for 5 the frequency is 1. So all the conditions are satisfied. So 2 comma 5 is a valid pair. Same 1 comma 5 is a valid pair, 1 comma 6 is a valid pair, and but 5 comma 7 is not a valid pair because although x is less than y, in this case 5 is less than 7, frequency of 5 is equal to frequency of 7, which um, which is not satisfied the condition. So I want to, the key observation in this problem is, let's say your smallest number is some number 8. Um, in the given array, the smallest number is, let's say, a. Now a has some frequency. Let's call it some numbers frequency of 1. Now for different for any other value which is not equal to a, that means for any other value b which is not equal to a, b will be greater than a by definition because a is our smallest value. Now, if b value frequency is not equal to f1, if this frequency is some f2 and f1 is not equal to f2, then our answer must contain the a as the first number because there exists a pair a comma b such that their frequency is not equal, which means our answer must contain a. So our approach can be like this. First, let's find the frequency of all numbers, and if all of the frequencies match, that means there is no distinct frequency number, right? All of the frequencies match, so we can't choose any pair at all because yeah, there is no pair. So in that case, the answer will be minus 1 because there is no frequency. Otherwise, if two distinct frequencies are there, that must mean there exists a number b which is greater than a, which frequency is different to it, right? Uh, this is the key observation here. If there are two different frequencies at least, then there must exist some b which is different frequency to the smallest number a. If we, if we take that, then our smallest number must contain a. So then it's easy to find out what is the smallest b for this, for which this is possible. We can go from the smallest number to the highest number by sorting them, and for each number we can check if its frequency is equal to the frequency of a. If it's not equal to frequency of a, we can just return a comma b. Otherwise, if the frequency matches for all the numbers, that means all of the numbers frequency are equal. In that case, we can return minus 1 comma minus 1, right? Let me show you my code for this problem. Now, if you can see here, I used maps because to store the frequencies, and I'm storing frequency of the smallest number in a variable called freq, and x is the smallest number which is present. As- yeah, and for every pair in the map, if the frequency of that number is does not matches with frequency of my first number, then I will just return first number comma second number. Otherwise, I will return minus 1 comma minus 1. I think this. I hope this clears your doubts. If it doesn't, then just let me know in the comments. I see that one of you guys solved 3 questions and one of you guys solved 2 questions. That's fair, I would say. The third question today is considerably difficult compared to previous questions, and I would say so. The fourth question is much easier compared to the third question. So don't don't feel bad if you just solve 2 questions because the third question today is considerably higher difficulty compared to normal. So that's the first question. Also, can you guys say if my mic is audible or not? Like, also, if you guys have any doubts, then yeah, just let me know in the comments. Now, let's just go to the second question here. Let me erase all of this first. Yeah, okay. Now, what is the second question saying? The second question is saying that there is a string s, which is all consisting of lowercase English letters, and there is an integer k. So we have a string s and an integer k. Now, two equal characters in the current string are considered close if the distance between their indices is at most k. If two characters are close, then the right one merges into the left. Merges happen one at a time. Here, merges means the right one disappears and the left one remains. That's the meaning of merges. And merges happen one at a time. And after each merge, the string updates until no more merges are possible. Return the resulting string after performing all possible merges. Right. If multiple merges are possible, then we should always choose the smallest left index and then smallest right index. Right. Now, I want to say something about this question. This question is very trippy at first. Like, at first, I didn't get any idea at all for this question. Then I checked the constraints, and apparently, the constraints is n equal to at max 100. So then I directly jumped to thinking of n cube solution, which fortunately is very straightforward in this case. It's just brute force solution. I'll give you a basic idea of what to do here. Let's take a string as an example. YYB, YZ, YBZ. Okay. YYB, YZ, YBZ. And K equal to 2. Which means we can remove at max two indices difference, at max two indices difference elements. That means if I am currently at this index, then I can remove this index. And if I'm currently at this index, then I can remove this index because the difference between these two is 2, which satisfies our condition. That means this merges with this and this will be gone. So now, but if you can see here, we cannot remove this and this because this distance is 3. So we cannot remove Z and Z. Now, the very brute force way is comes like this. Now, if you do a complete iteration in this array for the string, then there must exist one pair which merges to this element. Otherwise, that is the final string that we can get, right? That makes sense. So there can be at max O of n iterations that we can that we need to perform. In each iteration, there must be at least one merge. If there is no merge, then that means that string is the final string, right? So that's the first observation. Now, in each operation, we can go. If we fix the first element I, then we can check if in the vicinity of I, that means in from I plus 1 to I plus k, if there exists a character which is equal to y, like s of j is equal to s of I, where j is from I plus 1 to I plus k. If this condition satisfies, then we can remove that j, right? We can remove that jth index and concatenate the whole string and again do the operation. Because n is 100, if we let's say we fix the first element and we find nothing in the vicinity. Then we go to the second index and we find nothing. Then we go to the third index, we find nothing in the next k elements. For if we fix the ith index, then we can check in O of n time at max if there exists a number which is equal to s of I from I plus 1 to I plus k, right? That takes O of n time. Now there are total n character and n indices that we need to fix for each operation. That takes another O of n time. Now the total number of operations that are at max possible is 100, which is O of n. That means we can solve this problem in O of n cube. Do you do you guys have any doubts in this? If you have any doubts, then please say. And I will move on to the code part of this problem, which looks something like this. I'm fixing my size of the string, and I will do at max n iterations because there can be at max n operations as we discussed. And now there will be a boolean check. Why there will be boolean check? To check if there is at least one merge happening in that operation. If at least one merge happens, then we don't break. Otherwise, if there is no merge happens, then we break out of the loop right then and there, right? Now, how to check that? How to check if there exists a merge or not? Now, first, let's try to fix the first left index. Now, if we fix the left index, then the right pointer must be from I plus 1 to minimum of n minus 1, not n minus 1, the current size of the string minus 1 to I plus k. That is the maximum window that we can check because, yeah. Then if we can if we can observe any j which is equal to s of I, then I'm removing the j and I'm concatenating the part. How am I doing that? By doing this for loop. Basically, from k equal to j to current string length minus 1, sorry, minus 2, I'm basically doing s of k equal to s of k plus 1. That is, I'm left shifting all of the characters from j by 1, and I'm deleting the last character. That way, we basically remove that index and concatenating the remaining string. And because a merge is happening, I'm checking the boolean value to true and then breaking it, because what I'm doing is in one operation, in one while loop, I'm only merging the only once, right? So I'm breaking it and I'm checking if a merge already happened. If it already happened, then I can break out of this for loop and I can finally check if there is a merge happened. If there is no merge happened, then that is the final string and I break and I will return out of this loop, right? I think this makes sense. This is basically O of n cube solution. There is an optimized solution of O of n square, but I didn't think it was necessary to solve it here, so I didn't, right? And yeah, that's about it for this question. Now let's move on to the third question. I think this is a question a lot of you guys are waiting for. This is a tricky question in my opinion. Now, let's read the question together. What is the question saying? There is an integer array name, and an array is called parity alternating if for every index I from 0 to n minus 2. If nums of I nums of I and nums of I plus 1 are parity different. That means parity basically means what is the value mod 2, right? That means, yeah, one is even and the other is odd. In one operation, I can choose any index and increase the value by 1 or decrease the value by 1. What happens if you increase the value by 1 or decrease the value by 1? Then the parity of that number will be changed, right? Now, we need to return an integer array answer of length 2. That means we need to find two things here. The first thing we need to find is the minimum number of operations required to make the array parity alternating, right? That means if the first number is 0, then it should be 0 1 0 1 0 1 0 1 0 1, so on. If the first number is 1, it should be 1 0 1 0 1 0. Yeah. Now the second number we need to find is the minimum possible values of maximum of nums minus minimum of nums, or all the possible values in which um, it takes minimum number of operations. Now, if let's try to first find the answer of minimum number of operations required. If we can find that, then we can go to the second step of this process. Now, how to find the minimum number of operations required to make the parity alternating? One way you can think is by DP, but it becomes too complicated for no reason. One simple trick I want to say is this is the first observation. If also give me a minute, I will remove this board and now let's say there are some numbers 5, 4, 6, 7, 8, 10. Doesn't matter what numbers we have. To find the minimum number of operations that we need to make it parity alternating, we basically need the parity of each number. In this case, the parity goes something like this: 1 0 0 1 0 and then 0 0. Right? Because we can increase or decrease the value by 1 in each step, we can change the parity in at most one operation, sorry, in one operation. And if you do it two times, it will again come back to same numbers, same parity, which is redundant. So for every value, we basically need at max one time. We need to apply the operation at max one time. Now, as I said, in each operation the parity will change. Now, the first observation that we need to look is, let's say my first number is 0, my first number parity is 0, then the second number parity must be 1 because it should be alternating. Then the third number parity must be 0 because it should be alternating. Now the fourth number should be must be 1 and then 0 and then 1. One minute. Yeah. Um, Now, as you can see, if we fix the first number parity, then the whole array parity will get fixed. This is a required parity. Now, yeah, as I said, if we fix the first number parity, then the whole array parity will get fixed. Now, if we fix the first number parity to 1, then it will become 1 0 1 0 1 0. The whole array parity will get fixed. These are the only two possible parity sequences, right? Now, let's try to see minimum number of operations that we will take if we assume the first number parity to be 0. If we assume the first number parity to be 0, then we can we can go to the second number and then third number and the fourth number and check if the parity matches. If the parity doesn't match, we will do plus 1. Here the parity matches, so we will not do anything. Here the parity matches, so we will not do anything. Other again matches, we will not do anything. Now it didn't match. Sorry. Uh, Now it didn't match, so we will do plus 1 or minus 1. Basically, number of operations count goes by plus 1. We either decrease this element to 9 or increase this element to 11. Either way, the parity shifts to 1, which is correct. And then we will again check this parity, which is same. So we don't do any operation on that. But because we are fixing the first number parity to 0, we should also check this value, which is different, so we should do plus 1. In total, it takes 3 operations to make it as this parity. Now we can check the same for um, other parity too. Now if we check this other parity, this 1 and 1 matches, so we don't do any operation here. Now if I remove this whole thing, it took 3 operations, right? The first sequence, it took 3 operations. Now let's find for the other thing. This takes 0 operations. This again takes 0 operations. This takes 1 operation because the parity is different. This again takes one operation, this takes one operation, this takes 0, and this takes 0. Coincidentally, we got the same value, but it's not always the case that both the sequences will give you the same value. You should check for the both cases by fixing the first number to parity to 0 and then first number parity to 1, and check the for both sequences the minimum the operations it will take, and you can do minimum of operations 1 and operations count 2 to get your desired answer. That is the number of operations it will take to make that array parity. What is it called? Parity alternative. Is that clear? Um, I hope it is. And now, after this condition, what is he saying? 1 minute. After this, after we find the first value, which is the minimum number of operations, he's asking us to find the minimum possible value of max of nums minus min of nums over all arrays. Right, now this is the tricky part. How can you find this thing? Remember the first observation that I told, that is we should fix the parity of the first number. In the same applying the same principle, what we should do is we should try to fix the first number itself. That means, let's say if my array is 541320 5, this let's say 10 and then 9. Now if I assume the parity to be 010101, then I should change this to either 6 or 4 to match the parity. Now if I assume the parity to be 101010 so on, then this value should remain as 5, because the next parity which is 1, the next number which parity is 1 is 7, which we can't do, right? I mean we can do, but it's not efficient. That means 5 5 is the our number. Now we will try to fix 5. What will happen if we try to fix 5? It will become 5 itself, right? Of course. Now, as you can see, there are three cases here. The first case is the first number becomes 4. The second case is the first number becomes 5. The third number becomes 6. Now, put this off aside for a second. Now, let's try to think of one case in in which the first number is fixed. Okay, so there are three cases, and now we are assuming, now if we solve for one case, then we can solve for other two cases too. That is, let's say we have an array a1 a2 a3 until an, in which the first number is fixed, right? Which means at minimum the minimum will always be less than or equal to a1, and the maximum value of this whole array will be greater than or equal to a1, right? That makes sense. Now he is asking for us to find the max minus min value of this subarray. Initially, if we only have this one element, then the window will be a1 to a1. The range of the numbers will be from a1 to a1. If we increase our subarray size and goes to, let's say a2 is greater than a1, then it becomes a1 to a2, right? The window will always increase. It will never decrease, right? So our job is to make it so that the larger elements always decrease by 1, or the smaller numbers, if a3 is less than a1, then we should try to increase them by 1 if we try to change their parity, right? Now I'll take a one example and explain it so you guys can understand it more clearly what I'm trying to say. Okay, there are no good examples, but let's try this one. Minus 2, minus 3, 1, 4, right? Minus 2, minus 3, 1, and 4. The parities of this are 0, 1, 1, and then 0. There are two sequences here. It can be either 0, 1, 0, 1 or 1, 0, 1, 0, right? If we are if we are assuming the first number parity to be 0, that means we are fixing the first number to be minus 2. Then if we need to make a parity change here, if we don't need to make a parity change here because the parity is same. But here if you can see, we need to change the parity. Now, what is the best case scenario? Do you want to increase or do you want to decrease? Which of the conditions is better? If you can clearly see, minus 2, as we discussed, the window of min minus max will never decrease. It will always keeps on increasing, right? So we should always try to um, lower the values which are higher and higher the values which are lower. In this case, 1 is greater than minus 2. So if we make it 2, the difference will become 4. But if we make it 0, the difference will only become 2. So we should always try to lower this value, which means it becomes 0. We will try to make it so that it becomes 0. That should be our desired case. And even for 4, because the parity is different, we should try to make it to 3 instead of 5 because 3 is closer to minus 2, right? So as you can see, now the min minus max answer will become minus 2, minus 3, 0 and 3, right? So the answer will become 3 minus 3 plus 3, so it's 6. Is it 6? It is 6. But there are two more conditions that we need to check. Two more cases. One is the parity changes to minus 1. Other, again, the parity changes, but this time it's minus 3. We again need to check for both of these cases. Both of these cases works in the same very similar manner to the first this case that we check. We are checking the first. We are fixing the first position, and the parity is also fixed. Now, if the parity is different, we will try to bring it closer to the original value, and that's the thing. So there are three possible values for the first number, right? And if we fix the first number, we can find the max minus min value, right? Because we are always trying to, this is a greedy approach, right? If it's greater, we will try to reduce it. If it's less than our initial value, then we will try to increase it. That's it. But what if it's equal? That is an edge case here. Now I will show you with one example, with one good example. Let's say you have this array minus 4, minus 4, minus 3, minus 5, minus 4. This is actually a lead code test case. Now you have this array. Let's say I'm fixing the parity as 0. Okay, so this remains as itself. Now this parity is 0 and this parity is 1, this parity is 1, this parity is 0. Now this is different, so I need to change it. What can I change it to? I can either change it to minus 3 or I can change it to minus 5. It doesn't matter because the difference will remain minus 1. Sorry, will remain 1. Now if I'm changing this to, I need to change this to minus 4 or minus 2. You can clearly see that it's better to just change it to minus 4 because then if you change to minus 2 then the window will increase. So this case is clear. It should change to minus 4, but this case is not clear. It has two options, minus 3 or minus 5. Now minus 5 can go to either minus 4, minus 3, sorry, minus 6 or minus 4. Again, it's better to check, take minus 4. Now again, if it's minus 4, you have two options here, minus 3 or minus 4, because that is, I'm saying that because minus 4, for all the remaining elements, the final array will become minus 4. So it doesn't matter which one you choose, minus 3 or minus 5. It will give you the same array. But if you try to go by greedily and change it whenever you come across it, like you came across minus 4, and in this instance you try to change it to, let's say, minus 3, and you have some number minus 6 here, and you're getting it to minus 5, then it would have been much better to make it minus 5, right? Because then the difference in the window becomes 1. If you make it minus 3, then the difference in window becomes 2, which is not good. We should make it minus 1. So in this case, we should try to wait. Okay, we should try to wait. If our current number is equal to our initial number, we should wait to check which side we should go. If the difference, that is min minus max minus min, is equal to 0, that means all of the remaining elements which are not equal to this, all of the remaining elements are becoming the initial number, then we don't have a choice. Either we increase it by 1 or we decrease it by 1, right? That means if the difference it becomes 0 and there exists a number which is equal to our original number, which needs a parity change, then the difference becomes 1, forcibly 1. Now if the difference is already greater than 0, then I can always choose which side I can go, right? Then I will choose the side which is already there. Let's say in this case, minus 4 and minus 6, I'm changing it to minus 5. Then instead of minus 3, I can just change it to minus 5. In that case, um, the difference will not be affected at all. So if difference is greater than 0, it doesn't matter how many of these same things are there, it still says the same. Difference will still stay the same. The only edge case is if there exists a same number as the initial number and difference is 0, then you should make the difference as 1. Okay. Now, did you guys understand all of that? I hope you did, and please write down in comments if you do have any doubt. And that's about it for the problem. Like, now we know how to find the minimum parity count, and now we know how to find the max minus min value, right? That's good. So I will show you my code and take you to the thought process of mine for this code. Please forgive my bad code habits. It just happens. Now I'm making a function. I made a function which basically takes a vector, takes an array, and checks what is the minimum number of operations we will take for that array, and minimum value of max minus min, right? The only thing is, in this array, I'm assuming that the first number is always fixed, right? Then what will I do if I'm assuming the first number is always fixed? Then I can do directly the f of nums, and then I can decrease the value of f of nums by 1, and I can increase the value of f of nums by 1. I can check for the all the three cases the answers that I'm getting, right? But also I need to increase the value of number of parity swaps of this second value and third value, because I'm changing the parity, as you can see. So that's one thing that I'm doing. Now let's go to the function. In this function, because I'm fixing my parity one. I'm checking if my if my first number is odd or even. This basically tells me if my first number is odd or even. Now I'm taking a check value, which basically tells me if there is any number which is equal to our initial number. This basically exists for the edge case that I told you. If there any number which is at any index I greater than 0, which is equal to a of 0. Now let's start from the first index. Now if the parity is not same, this basically tells me if the parity is not same, then I will increment my changes count. That means it's basically is the number of changes. And after increasing my changes count, now I will see if array of I is not equal to array of 0. If array of I equal to array of 0, then I'm basically checking this true, which we will use it later. But if array of I is not equal to array of 0, and if array of I is less than array of 0, then I will increase that array of I. Otherwise, I will decrease that array of I to minimize the difference of the sliding window, right? No, not sliding window. To minimize the difference of the window. Yeah. Then I'm changing the parity because for each number the parity alternates. This is the parity. This basically this odd variable is telling me what should be the parity of my current number, right? And after that, I basically took two numbers which is the max element and which is the min element, right? And I'm finding the difference of the max element minus min element, and I'm taking it. I'm seeing if the check is true. If the check is true, that means there exists an element which is equal to my first number. If that happens, then this edge case exists. If difference is equal to 0, then I should make the difference to 1. This is the edge case that we discussed earlier, and I'm returning the number of changes that we made and the difference of max minus min in in a vector. That's basically it for this question. So I'm first finding if I fix the first number to itself, then what is the number? Then what is the answer? Now I'm changing. I'm decrementing the first value by one. Then I'm again finding the value. Then I'm increasing the number by one. Then I'm again finding the value. Because I'm changing the parity for the second and third vectors, I should increase the parity count by one because yeah, now I pushed all of the three vectors into a vector of vector and sorted it and returned the first number. This is basically to return the smallest nums of smallest array. Is this clear? If there are any doubts in this question, then please tell in the comments. I will wait for a minute. Okay, so I'm assuming that it's clear to all of you. If that's the case, then that's good. Now let's jump to the straight to the fourth question. What is the fourth question saying? The fourth question is actually pretty straightforward this time. It's it's basic combinatorics, and yeah, let's read the question. There are three integers L, R, and K. Consider all possible integers consisting of exactly k digits, where each digit is chosen independently from the integer range L to R inclusive. If 0 is included in the range, leading zeros are allowed. Then return an integer representing the sum of all such numbers. Now, if you guys didn't understand this question, let me explain this. Let's say my L is 2 and R is 4 and K is, let's say, 3. Okay, what do you say? There are K number of digits. That is, there are 3 digits. In all the 3 digits, what I can do, I can fill all of the digits with ranges from L to R, any of the number from L to R. That means I can either fill the first number with 2 or 3 or 4. Same other, again I can fill the first number with 2, then 3, then 4. Again, the third number with 2 or 3 or 4. If you guys clearly observe that there are a total of r minus l plus 1 ways for the first number to be filled, then r minus l plus 1 for the second number, then r minus l plus 1 for the third number to be filled. So there is a total of r minus l plus 1 power of k possible numbers because leading zeros are allowed, right? That's the first observation. Now, basically this question comes under contribution technique, okay? Our idea should be something like, let's say if I fix this one number, no, what I mean to say is, what is the value contributed by this one digit? If I can find that number for all of the digits, then I can, let's say this value is A, this value is B, this value is C. Then I can find A plus B plus C. If I do A plus B plus C, then that's the contribution of the whole number, right? Now, that's one thing. Okay, what is a digit is contributing? How much is a digit contributing? How to calculate how much a digit is contributing? Now, let's take for one digit, which let's say k is equal to 5 and we have 5 numbers, right? And we are calculating this digit contribution. For this digit contribution, there exists a number from L to R in, and then there will be 3 zeros, right? And the sum of all possible values will be the contribution by that digit. How many values are possible from L to R, right? Basically L into 10 power 3 plus L plus 1 into 10 power 3 into so on until R into 10 power 3. This is the contribution that is made by this one digit. If we can find for all of the digits that this value, then that's basically we're finding the whole thing. Now if we try to brute force this thing, this is basically O of R, right? And then this basically is O of K. So of or R times O of K, so of R times K, which definitely exceeds the time limit because K itself is 1 in 9 in our question. Now how to solve this? If you look carefully here, this value for each digit, what is this thing? This is the total contribution by a single digit, right? Now let's generalize this. Instead of 10 power 3, let's generalize this a bit. Let's say, I'm sorry for that. Let's generalize this a bit. If I have three numbers, L comma R comma K, that means K digits. If I am, let's say, at ith digit, then I have I minus 1 zeros. Okay, that means whatever this value is, whatever the digit it is at, that is multiplying by 10 power I minus 1, if you can see. Um, So for the first number, it's basically is 10 power 0. The first this for the second number, this becomes 10 power 1. For the third number, it becomes 10 power 2. And for the last number, this basically becomes 10 power k minus 1. Right? That's good. Now, that basically means we should, what are we supposed to do? Let's see. We are trying to fix one digit, right? Uh, that is the contribution of whatever the value we get, some number, some value, that times 10 power I minus 1, from I equal to 1 to I equal to k, right? This is our answer. Now, we can do this a bit easier by making this I equal to 0 to k minus 1 and this as I itself. This is a value. What is a value? That is the contribution made by each digit. How much is that? Let's see. Let's see that now. Now, how can I do this? One second. Can I do something like this? Okay. Oh no. One second, guys. I'm putting this somewhere here, right? Now, we should try to find the value of each digit. Now, let's say I'm at some digit, right? How many distinct values are possible? Like how many distinct uh, numbers are possible? Fr- that answer is from L to R. L to R numbers can exist, right? If I fix in that digit, let's say I'm fixing L as the digit for that number. In how many numbers will I get L as my digit? Now that's something we should find. If I have, let's say, length of k, and this is one number. Now this has, as we previously discussed, r minus l plus 1 possible ways to fill this number, and to fill this number, and to fill this number. Now I'm fixing this digit specifically to l, and I'm again choosing r minus l plus 1, and so on. Now, if I'm fixing a particular number in that digit, there exists r minus l plus 1 times k minus 1. This many number of ways, because r minus 1 l plus 1, so r minus l plus 1 is coming a total of k minus 1 times, excluding this ones which we are fixing. So this digit l, I mean like that specific number L at that digit is contributing a total of L into R minus L plus 1 power K minus 1. Okay. This into 10 power, whatever this digit number is, let's say this digit index is I minus 1. That is the total contribution of this digit at this particular number. We already saw that this is 10 power I contribution. So if we explode this, that means we are only looking at the value this is contributing. That is this, right? Now, this number, there can be multiple numbers here, not just L. There can be L plus 1, L plus 2, and until R. So the same thing will happen. For L plus 1, there will be R minus L plus 1 power K minus 1 numbers. Possible numbers exist. And for L plus 2, again, r minus l plus 1 possible numbers exist, and so on. We will get r into r minus l plus 1 power k minus 1. Okay, right. Now this, if you look carefully here, this is basically sum of L2R into R minus L plus 1 power K minus 1. This is the value of this, right? But if you see clearly, this value is constant for every digit. For every digit, the contribution by a single number is same, but the only thing that is changing is the 10 power I thing. If we can find this value, let's say this is some constant c, we can push out this constant aside and it basically becomes c into I from 0 to k minus 1 10 power I. This basically is geometric progression and we can calculate that very straightforwardly. Now that is clear. Now how to find this value specifically? Sum of L2R to this. This again, if you guys clearly see, this is a constant R minus L plus 1 to power K minus 1. This is a constant, so we can calculate this pretty easily. Now all we need to calculate is sum of L to R. This is basically a geometric progression with the difference 1. Now we can use apply geometric progression formula, but I will there is also one simpler way. It's sum from L2 R is L plus 1 L plus 2 R is sum of 1 to R minus sum of 1 to L minus 1, right? This value that basically means it's sum of R plus this value minus L into L minus 1 by 2. This value is the sum of R and L to R. Now this is getting a little janky. 1 second. That is the total value. Now we can get that constant. The constant is basically C equal to R into R plus 1 by 2 minus L into L minus 1 by 2 into R minus L plus 1 power K minus 1. This you can find out in O of one time. So we can find the constant in O of one time. Now, as we previously discussed, now this value is C. This is basically value variable. Now all we need is to common out that value, sorry, take out that value out of the sigma and find the value of this I equal to 0 to k minus 1 10 power I. This basically is geometric progression 10 power 0 plus 10 power 1 plus until 10 power k minus 1. Now if you can see, this is basically 1, so the geometric progression says r into n plus um, r into n plus 1 minus 1 by r minus 1, right? So this basically becomes a equal to 1, so and r equal to 10, so this basically becomes 1 into 10 power k minus 1 plus 1, which is k minus 1 by 10 minus 1. That means uh, the total answer becomes val into 10 power k minus 1 by 10 and 9. Now, because you're taking the mod value, mod of everything, you need to find the mod inverse of this and you need to multiply the mod inverse of this with this whole thing. So the whole question becomes an O of one question instead of the brute force is O of n square, right? So O of r into k. But now it became an O of one question. And that's about it for this question. I will show the code for this question. 1 second. Now I made use of some template I had for LeetCode modulo operations. This is basically to find the modulo multiplication, modulo addition, modulo subtraction, modulo exponentiation, and modulo inverse. Okay, that's all. That's all template. And there are only 4 lines here. The first part is I'm finding the value of r minus l plus 1 power k minus 1. that's what I'm doing here. This basically is doing r minus, one second, r minus l plus 1. Whoa, something is happening. Oh, oh, sorry, my pen is not working correctly. But yeah, this is basically r minus l plus 1 power k minus 1. And the sum is basically the sum of digits from L to R. That is R into R plus 1 by 2 minus L into L minus 1 by 2. And the second term is 10 power k minus 1 by 9. This is basically the sum of GP, right? And I'm multiplying all these three values, and that is my answer. And that's about it for this contest. I will say this contest is a pretty different from usual experiences. The third question stuck out to me the most, and the fourth question is enjoyable if you're just starting out CP, because combinatorics more often than not is taking a huge number and making it into a closed form number, which is basically what we are doing here. We are taking it of r into k, which is a very big time complexity, into of 1 or of log n, let's say, because mod expansion takes log n time. But yeah, so that is pretty fun challenge if you're just starting out combinatorics. And this third question, as I previously said, requires some observations and some effort. And yeah, that's about it. It basically becomes a greedy question, and as we all know, LeetCode loves greedy questions. And that's about it. The first two questions are something. The second question is obviously a bit tricky until you see the constraints. Then it becomes basically a implementation question, brute force question. And the first question is whatever. But yeah, that's about it for this contest. I will wait for a few minutes. If you guys have any doubts on any of the questions, please write them down in comments. Otherwise, I will take my leave. Okay, so I'm assuming you guys don't have any doubts. And yeah, thank you for watching. I will take my leave now. And